Okay, here we go. All right, so looking at this, what do we have to calculate? So we have a point A and a point B. This has one reactionary force, this has two. All right, so far we know we need to get an RA in the X direction. We have to get an RB in the X direction. And we have to get an RB in the Y direction. So far, so good. Now, what else do we need to get? So then we need to figure out our forces. What are the forces of the members? So our forces of the members, we will have force of AB. We need force of BC. And we need force of AC. So those are all the ones we need to figure out. So step one will always be doing the sum of the moments. And as we've mentioned, well, not at X, just sum of the moments. As we've mentioned before, you always start as your pivot point with the pin. So the pin will be the pivot point for this one. So what we're going to have to do is calculate the forces. So we have, every force has to be with the distance perpendicular, right? So if we have this pivot point here, this force is there, the perpendicular distance from it will be 3 feet. So, and it's also going to be clockwise, and clockwise is negative. So we would have negative 50 pounds of force times 3 feet. Okay? What else are we going to have? The other force that's going to fight against it will be the force of RAX fighting against it there. That's an R. Okay? So that is going to be counterclockwise, which means it's positive. So we have plus RAX times its horizontal or its perpendicular distance, which is also 3. All right, and that some of the moments will add up to 0. Okay, so we have we can do a little algebra. This is a negative 150 plus 3 times RAX is equal to 0. Do a little algebra. 150 goes on both sides. 150. So we have 3 RAX is equal to 150, and therefore RAX is equal to 50, because I divide both sides by 3. All right, so far we got one. Whoa, look at that. RAX. All right, now let's do the sum of the forces. Let's do some of the forces in the Y direction. So far we only have, if you look at all, you look at step number 2, we're going to do the sum, try that again, sum of the forces in the Y direction. What forces do we have going on? Well, we have the 50 pounds of force. That's going down, so I'm going to make that negative. All right, and the R and the A, that's a pin, so there's no, there's a roller, so there's no force in the Y direction from that. The only reactionary force we have is from the pin of B. So we can say RB in the Y direction. All right. Now, they add up to 0 because it's not accelerating downward. So we can do a little algebra here. Add RBY to both sides. Add 50 to both sides to get RBY by itself. And we get RBY is equal to 50. So there we go. RBY 50. All right. Next, let's do the sum of the forces in the X direction. All right, what do we got in sum of the forces in the X direction? I'm going to move this around a little bit further down. Nope. Try that again. Try it a third time. There we go. Okay. So sum of the forces in the x direction. What do we have? The only force I see going, oh, I know, I'm sorry. We got two forces. We got the RAX, that's x direction, and we're going to have R BX over here. Okay, so we have RAX plus RBX. And that is equal to 0. All right. Now, we already know what RAX is. That's 50. So if RAX is 50, we can do that. Sum equals 0. And again, sum equals 0 because it's not accelerating to the right or the left. So we do algebra here, minus 50 from both sides. And that means that we have RBX is equal to a negative 50. And really the negative here just means direction. It means it's going to, if RAX has to push to the right, RBX has to be pushing to the left. And that keeps it in place. All right, let me clean that up a little bit. Okay. All right, what else do we got to do now? So now we can start looking at the joints. Okay, so we have some things listed here. That's great. Now let's start looking at the joints and see what we got. So I am going to have a little space for A. And I'm going to do A. Oops. I'm going to get a little space here. And I'm going to do A. All right. A. We have two things. We have the x side and the y side. We got the horizontal and the vertical that we got to deal with. Okay, so let's look at that. I'm going to split it up into x and y. I'm going to probably move that away somehow. Unlock it and move it. Sorry. Okay. All right, so let's say ax and we'll say ay. All right. So sum of the forces in the x direction. What forces do we have going on in the x direction at joint A? Well, we know we have RAX. And we know we have AC. Okay, and we know that adds up to 0. Let's substitute in. We already know RAX, which is awesome. So we're going to do 50 plus AC is equal to 0. Do our algebra, minus 50 for both sides. And we get AC is equal to negative 50. Okay? So AC is equal to negative 50. So we can get that one already put in here. Now, negative means compression. It's important to remember that. All right, so now what about in the y direction? Well, we have force of A, or some of the forces in the y direction here. Well, what do we got? What forces do we have acting on? The only thing going vertically is AB. So AB plus nothing is equal to 0. So that means AB is equal to 0. AB is equal to 0 newton. So that means this beam is really not doing anything but sitting there. There's no force in me, no stress, no compression, no tension happening on it. All right, so there we go. That's a good one right there. Let's do B. So we're going to do B in the X and B in the Y. All right, so let's list our forces of B in the X direction. So far we know, so for the sum of the forces in the X direction, we are going to have, Well, we got RBX, which we already know. Okay. What other forces do we have? A component of this BC, because that's at an angle. So we can't just say BC, but we can say the X component of BC. So we'll say BCX. Okay? This is purely vertical, so that won't be anything for us. So that's it. All right, so that's going to add up to 0. We have RBX is equal to negative 50 plus BCX is equal to 0. Do a little algebra, add 50 to both sides. So I have BCX is equal to 50. Now what we should have done before, but I'll do it now, is figure out this angle here. Okay? So we have our length here is 3 feet. I'm sorry, the horizontal piece is 3 feet. So not the diagonal, but the regular. Okay, the horizontal. And the vertical is 3 feet. And if you know anything about special triangles, that is a special triangle because it's equal. So I got 3 feet and 3 feet. So that means our theta here, our angle is going to be 45 degrees. And that will be helpful. Okay? Looking at this, just this little side note of it also. So we have our angle. And we also know that the components, so BCX, the X component, BCX, is equal to BC times cosine 45 degrees. Okay, cosine of the angle. BCY is going to be BC times sine of 45 degrees. And of course, we know they're equal. All right, so if BCX is 50, then we can plug in that we know that BCX is equal to cosine of the angle. Whoops, BC times cosine of the angle. So let's plug in what we know. We know this is 50. We don't know BC yet. We know that the angle is 45 degrees. We divide both sides by cosine 45. Yoink, yoink. And we get that BC is equal to 50 divided by cosine of 45 degrees. Plug it into a calculator. 50 divided by cosine 45 is 70.71. So BC is 70.7. And there we go. We have figured out everything we need to figure out for that problem.